Hello friends, this is Vaibavlakshmi, EC student at Tyagaraja College of Engineering, Madurai. I am going to give a quick recap about an amplifier before moving on. Amplifier is an electronic device that amplifies a signal, that is, it has a power gain greater than 1. A basic classification of amplifier is inverting and non-inverting amplifier. In an inverting amplifier, the output voltage is 180 degree out of phase, that is, opposite in direction to the input. The circuit is as given. The non-inverting terminal of the operational amplifier is grounded and the feedback circuit is on the inverting side. The golden rules regarding an op-amp are: the current through the operational amplifier is 0, that is I op-amp is equal to 0, and the differential input voltage is equal to 0, that is a virtual ground exists. Now we will take a look at the formulae involved and their derivations. We know that the current I is given by Vin minus Vout by Rn plus Rf. I is equal to Vin minus V2 by Rn, which is also equal to V2 minus Vout by Rf. So moving the V2 terms to the right hand side, we get Vin by Rn equal to V2 into 1 by Rn plus 1 by Rf minus Vout by Rf. But Vin minus 0 by Rn is equal to 0 minus Vout by Rf, which gives Vout by Vin is equal to minus Rf by Rn. Thus, we have calculated the gain. It can be transposed to give Vout. That is, Vout is equal to minus Rf by Rn into Vin. The negative sign indicates the 180 degree phase shift and that the feedback is negative. The waveforms are as depicted. But where do we make use of this concept? We use this as a phase shifter in integrators for balancing signals, in mixers for radio frequency signals, and in sensors. Advantages: it allows negative feedback. The gain factor is huge. The output will be out of phase with respect to the input. The potential values across the inverting and non-inverting terminals are maintained at 0. Drawbacks: noises could affect the signal, and there are high chances of distortion. Now we move on to the non-inverting amplifier. It is just the opposite of an inverting amplifier. That is, the output is not inverted. It is a basic amplifier circuit, and the circuit is as follows. Here, the inverting terminal is grounded. Similar to the inverting amplifier, we derive a formula. V1 is given by R2 by R2 plus Rf into Vout. For ideal cases, V1 is equal to Vin, and the voltage gain is given by Vout by Vin, which is equal to R2 plus Rf by R2. This can be further simplified as AV is equal to 1 plus Rf by R2. We have now learned that the overall closed loop gain here is always positive and greater than or equal to 1. By changing a few configurations, we can convert an inverting to non-inverting amplifier and vice versa. The waveforms are as follows. A non-inverting amplifier is used for high input impedance circuits, to isolate cascaded circuits, and to vary gains. Advantages: there is no phase inversion. There is higher impedance compared to inverting amplifier. The matching is better, and finally the voltage gain is variable and positive. The disadvantages are the number of stages required are more, and the input and output resistance get varied. We can now conclude that a good understanding and a judicious use of these amplifiers can make a circuit more effective. Thank you all and goodbye.